What is tissue sectioning? Tissue sectioning is a critical step in histopathology. Tissue sectioning is the process of cutting tissues into thin slices for microscopic examination. The process begins after the tissue specimen has been properly fixed and embedded and making it suitable for cutting. These tissue sections, typically 3 until 4 micrometers, are crucial for accurate staining and detailed observation under a microscope. Did you know that there are two primary methods of tissue sectioning, frozen sectioning and paraffin sectioning? Each has unique applications and techniques suited to different types of analysis. So let's find out. Frozen sectioning involves cutting thin sections of tissue that are kept frozen and cut within a cryostat. While frozen sections are less stable than those prepared with paraffin, they offer superior preservation of antigenicity and lipid content. So, how about paraffin sectioning? Paraffin sectioning involves slicing thin sections of tissue that's been dehydrated and treated with wax. This tissue is embedded in wax and then cut on a microscope. Paraffin sections are more stable and better at preserving tissue structure compared to frozen sections with less risk of damage. However, the wax infiltration process makes these sections less suitable for certain staining techniques.
Rotary microtomy. You can make thin slices with a rotating microtomy by moving the sample upward and downward throughout the blade of the instrument. First, the method is tedious because the tissue must be fixed, dehydrated, embedded before slice. It consumes a lot of time. Second, it demands operator skill because section ribbons will become twisted due to static charge, particularly in dry air, and it will be challenging to unfold them on the warm water surface. If it is too harsh, it could tear the tissue section. Third, the use of rotary microtomy produces a vibration, thus result in inconsistent tissue thickness. Fourth, the cutting capability is limited, where no serial section is possible. Fifth, potential hazard. Lab personnel may be exposed to hazards when handling the equipment. Lastly, limited block size, where the size of block that can be cut is limited.
Does the rotary microtomy method affect the result? The answer is yes. The rotary microtomy method can affect the result of sectioning. There are 4 factors can affect the result of rotary microtomy method. First, a stable work surface is indeed a critical factor in producing high-quality sections in microtomy. A solid, stable bench prevents vibrations during microtomy, reducing artifacts like undulations and chatter. Microtomes should never be used on unstable surface as vibrations can result in uneven and poor quality section. Second, proper knife tilt or clearance angle is indeed an important factor that affects the quality of microtomy result. The clearance angle should be set to 3 until 8 degrees depending on the blade used. Once properly adjusted, this angle should rarely need changing as it optimizes cutting and reduces artifact. Third, properly clamped microtomy parts are indeed crucial for achieving high-quality sectioning results. All parts of the microtomy, including the blade clamp and block holder, must be securely tightened. Loosely clamped parts cause vibration that lead to washboarding patterns in section. Lastly, consistent cutting speed is indeed an important factor that affects the quality of microtomy sections. Maintaining a steady cutting speed that means around 1 rotation per second is crucial. Fast cutting can cause thickness inconsistencies, while slower speeds can create uneven sections that affecting ribbon formation.
Now, I will be presenting on the adoption of new technology in tissue sectioning, which is known as the Aquatic Sectioning Transfer System CUT6062, and how the Aquatic Sectioning Transfer System is revolutionizing this critical aspect of scientific research and medical diagnostics. The aquatic sectioning transfer system is designed to enhance both the safety and efficiency of tissue sectioning with a clear focus on operator protection, precision, and adaptability. Firstly, ensuring operator safety and control is a top priority with features like control locking mechanism, safety guards, and several adjustments that protect the technician during critical operations. For example, the integrated finger guard and hand wheel locks prevent accidental engagement with movement parts, offering peace of mind while performing blade adjustments and specimen handling in high precision environments. Secondly, the system's versatility and adaptability are key for accommodating a wide range of specimen types. With adjustable components and interchangeable clamps, the aquatic system allows for the seamless handling of specimens of various sizes and shapes, from small biopsies to larger tissue blocks. The ability to easily swap out clamps and modify blade profiles make it a flexible solution that supports different cutting needs across diverse applications. Thirdly, precision control and alignment are central to the system's performance, as accurate specimen and blade positioning is crucial for consistent, high-quality sectioning. The aquatic system features advanced alignment mechanisms that ensures both the specimen and blade are positioned with pinpoint accuracy, resulting in uniform, distortion-free tissue sections ideal for diagnostic and research purposes. Fourthly, the system promotes efficient setup and consistent operation, streamlining workflow and reducing the potential for error. With motorized cores and fine adjustments and memory functions that store previous settings for specimen fit, technicians can rapidly set up and fine-tune the system for reproducibility across multiple sections, thus saving time while enhancing productivity. Next, optimized blade and knife control plays a pivotal role in achieving high-quality tissue sections. The aquatic system ensures secure blade fixation through customizable clamping and angle adjustments, reducing blade drift and vibrations. This results in sharper, cleaner cuts that produce uniform sections, crucial for accurate histological analysis. Lastly, the system's efficient positioning and approach mechanisms, including adjustable hand wheels and precision guide rails, allow for smooth and accurate specimen and blade positioning, ensuring consistency in section thickness and alignment across each cut. Together, these features ensure that the aquatic sectioning transfer system is a highly effective, safe and versatile tool for achieving precise and reproducible results in tissue sectioning. Now, I will explain on how the aquatic system affects the diagnostic process. Firstly, precision in tissue sectioning. One of the key features of the aquatic system is its ability to produce highly consistent thin tissue slices. This precision ensures that the cellular architecture of the tissue is preserved in great detail. Accurate cellular features such as the organization, shape, and appearance of cells are crucial for pathologists when diagnosing conditions like cancer, where even subtle differences in tissue structure can be indicative of malignancy. Thin, uniform sections allow for a clearer view of these details, reducing the likelihood of missing critical pathological markers. Secondly, reduction of artifacts. A common challenge in histopathology is the presence of artifacts such as folds, wrinkles, and compression marks, which can occur during tissue sectioning. These artifacts can obscure important details and lead to misinterpretation. The aquatic system minimizes these artifacts by offering precise control over the cutting process. By preventing tissue distortion, it ensures that pathologists can examine undistorted samples, which is especially important when evaluating subtle or complex tissue features such as tumor boundaries, cell morphology, or other key diagnostic criteria. Thirdly, improve workflow efficiency. The speed and accuracy of the aquatic system make it an invaluable tool in high-demand laboratories where timely diagnosis is crucial, particularly for urgent cases like cancer biopsies. By facilitating faster sectioning without sacrificing quality, the system helps streamline lab workflows, allowing for quicker preparation of tissue samples. This efficiency accelerates the overall diagnostic process, helping pathologists make more timely treatment decisions, which can be critical for patients awaiting diagnosis or surgical interventions. Next, enhance consistency across samples. Achieving uniform tissue sectioning is vital for comparing different samples, especially in longitudinal studies or cancer staging. In cases where a patient's condition is being monitored over time or when comparing biopsies from different anatomical sites, consistency in sectioning ensures that the analysis remains reliable. The aquatic system delivers uniform thickness across all tissue sizes, allowing pathologists to make accurate comparisons between samples. This is particularly important in cancer staging, where minute differences between sections can indicate the progression of disease, and in research settings, where consistency is key for valid scientific conclusions. Lastly, reduce risk of sample damage. Tissue integrity is essential in histopathology, particularly when working with delicate or fragile tissues such as those from the brain, lung, or other organs that are prone to tears or distortion. The aquatic system minimizes the risk of damaging these sensitive samples during sectioning. By offering precise cut capabilities, it helps maintain the structural integrity of the tissue, preventing mechanical damage that could compromise diagnostic accuracy. This ensures that the pathologist has the most accurate representation of the tissue, critical for conditions where tissue architecture plays a key role in diagnosis, such as in neurodegenerative diseases or pulmonary conditions.
Firstly, flexible water circulation. It minimizes tissue section degradation, resulting in more usable section per block. Second, smooth section extension. Sections extend as a result of the smooth flow of water. This leads to excellent sectioning outcomes. Third, adjustable water temperature. The temperature of the water is user selectable from ambient to plus 50 degrees Celsius. Fourth, illuminated water bath. The illuminated aluminum water bath provides exceptional section visibility. Fifth, detachable blade holder. The equipment has specially constructed detachable blade holder with transfer ramp. So, the traditional hand transfer of the parts into a water bath is no longer required. Sixth, reduce section width. 7. Built-in blade ejector for safety. And lastly, easy cutting and simple creation of creation ribbons.
In conclusion, the adaptation of advanced technology like the aquatic sectioning transfer system (CUT 6062) has greatly improved tissue sectioning in histopathology. While traditional rotary microtomes were reliable, they had limitations such as manual handling, inconsistencies, and potential sample damage. The aquatic system offers precise automated blade control, ensuring consistent section thickness and reducing errors. It minimizes artifacts, which is critical for accurate diagnostics, especially in complex cases like cancer. The system also enhances workflow efficiency, allowing faster processing without compromising quality, and preserves delicate tissue integrity, which is vital for accurate pathology assessments. Overall, the aquatic system improves diagnostic accuracy, reduces errors, and leads to better patient outcomes.